Welcome to the new model on geothermal energy. A new model highly justified by the ongoing worldwide discussion on energy and climate. Knowledge and action are needed. Geothermal energy, extracting heat from the subsurface rocks for a society less dependent on fossil fuels. Because the energy density of geothermal fluids is significantly lower than that of other sources such as hydrocarbons, the economical use of geothermal sources requires accurate predictions of the characteristics of the subsurface and of its response to exploitation. Your skills are needed and will be needed in the future. Introducing you to this knowledge is the goal of this new module. One of the main reasons to expand the use of geothermal energy is the global warming caused by the CO2 emissions associated with fossil fuels. This is the famous hockey stick plot documenting the link between CO2 emissions and temperature increase. Predictions of energy sources needed to sustain the welfare growth in the world, and especially in the less rich countries, show that we will need at least 30% more energy than what we're using today. In order to decrease as much as possible the amount of CO2 emissions, the cocktail of different sources will change dramatically. Coal, at present very common because it is very cheap, will decrease. Gas, the less polluting type of fossil fuel, will increase. The largest increase will be, however, in terms of renewables. Geothermal energy can and must play a major role in achieving this goal. It is a renewable, baseload source of energy. As an example, in the Netherlands, where we're recording these clips, aim at increasing geothermal production by a factor of 10 within the next 20 years. Geothermal energy is a source with a long history, already widely developed in Roman times. There's been in the last decade a major increase in installed capacities. Many countries are working hard to develop geothermal resources for heat production and for electricity. The world champion is clearly Iceland, which has the highest energy production per inhabitant of the world. Countries like Sweden, New Zealand, and Turkey are also doing well. Sweden and Switzerland use most of their production for heating. Countries such as Kenya, on the other side, have a significant production per person, but mainly focus on electricity. Not so strange, given the average high temperature of those countries. Now let us look in more detail how is energy used and what types of energy are needed. Energy is needed for transportation, to heat residential and commercial premises, to run factories, and to produce electricity. According to the data shown, electricity production requires the highest amount of energy. Also note that in all categories, the energy consumption is foreseen to increase, with the exception maybe of residential. The source of energy needed for the various uses changes enormously. Oil is the main source of fuel for transportation, and notwithstanding the increase of electric cars, will not change dramatically in next years. A comparable trend can be seen for industry, where replacing gas and other traditional sources will be very challenging. On the contrary, geothermal and other renewables will play a major role in electricity production and in heating for residential and in large complexes such as hospitals, and even in many industrial activities such as greenhouses, aquaculture, and so on. These are ideal customers for geothermal energy. In addition, geothermal energy is always available and forms the base load, compensating inherent fluctuation of other sources of renewable energy. But does geothermal energy provide the answer the world needs? To answer this question, we need to define the different types of geothermal system. The first type is based on hot fluids, typically above 150 to 100 degrees, which are used for the production of electricity. These systems are called high temperature or high enthalpy. A second group includes direct heat production from aquifers at 70 to 90 degrees and is named informally low temperature system. The third group involves a variety of systems in which the subsurface is used as a storage for heat to be used when convenient. We will look at all these three groups during this module. To answer the question of how much heat is accessible for society to use, we need to go back to the geology of the Earth. Remember the clips you looked at a couple of weeks ago? Now the gradient in the uppermost kilometers of the Earth, that is, the temperature you will find at a certain depth, depends on two sources of heat. The background heat is simply due to the fact that the core of the Earth is hot and that cooling takes place. In the lithosphere, the resulting gradient is relatively low, in the order of 10 degrees per kilometer. In the crust, however, there is another source of heat represented by the radioactive decay of the elements which occur in minerals such as feldspars, which are common in granite, sandstones, and other rocks. This results in a normal crust geothermal gradient around 20 to 40 degrees per kilometer. As we will see, this is enough for low temperature geothermal, but not for high temperature activities. Now, the figure on the screen is a map of the heat flow model at the Earth's surface. As you know from previous clip, the heat flow is proportional to the gradient and is therefore a good proxy of the temperatures you will find at a given depth. To give you a rough idea, in areas where you have a heat flow of 30 milliwatts per square meter, you expect to have temperature of 60 to 90 degrees at relatively shallow depths of 2 to 3 kilometers. All areas with heat flow values above 20 to 30 milliwatts per square meter are potentially well suited for low temperature geothermal exploitation. There are many similar places in the world. Some areas have very high heat flow values, sometimes larger than 100 milliwatts per square meter. These are localities ideal for high temperature thermal systems. Areas with very high heat flow are generally located in zones where the region extension takes place, such as long continental rifts like the East African Rift. Areas of high heat flow are also located in regions of intense magmatism, such as the corresponding with subduction zones. Intense magmatism also takes place along mid-oceanic ridges. These are typically underwater, but one segment of it outcrops at the surface of the Earth, namely in Iceland. In next clips, we will see more of this incredible place. Low temperature geothermal systems require sufficiently high temperatures, but also layers of rocks which are permeable enough to allow efficient circulators of water. These fluid pathways are called aquifers and are bounded by less permeable layers called aquitards, seals or cap rocks. Typical seals are made of impermeable rocks, for instance, the shale shown in this picture. Fluid pathways can form because of high primary porosity, as it is the case of sandstones, or because of the occurrence of a well-developed network of open fractures, such as the one shown in the figure. The permeability of the target layers is a key factor in determining the economics of the geothermal operations. Strong geological skills are needed to predict the geothermal energy which can be generated. High temperature geothermal systems are those where waters at very high temperature are tapped. Temperatures so high that the fluids move in a convective fashion. High temperature systems also require fluid pathways, typically formed by fractures. These systems produce electricity as well as heat. Like all industrial activities, extracting energy from the subsurface is not devoid of risks and challenges. Production and stimulation of permeability can lead to pressure changes in the aquifer, which can result in unwanted effects such as leakage through the seal and movement along faults causing some seismic activity. Accurate modeling studies fed with well-constrained parameters are always required to quantify these risks and minimize them as much as possible. Another challenge facing underground operation is related to interaction with the local communities and with the other groups of citizens. The topic is obviously complex, but it is clear that without a rigorous and transparent risk evaluation, the discussion will be very difficult. Enough as an introduction. Time to start. This model of GeoMOOC 2019 will address the three main components of geothermal systems: high temperature, low temperature, and storage activities. As in previous models, we will have exercises and tests. Stay on board, refresh your geological knowledge, and do not hesitate to participate in the discussions.